Hello and welcome to this video. In this video we will solve 22nd or 23rd set of problems, that is problem number 221 to 230. But first I will show you again how to download this PDF. So you can go to my website www.astavaka.org. There is no need to type www, just type astavaka.org, it will redirect you. Now go to this second item in the list, a variable in algebra. The date will indicate when was the last update. Usually I modify it after making the videos when I find the typing issues and all that. So you can see it was updated 4th December. And trigonometry book is also complete, almost complete. Maybe 2 months more and then I'll finish this. So if you click that link, it will open, the book will open. And we will do the problems of quadratic equations. You can save this video using this icon. In Chrome it might look different, but this is your icon. You say click save and the PDF will be saved on your mobile or laptop or desktop. So with that out, don't worry about the link, I'll paste it in the description of the video. All right, now we come to the problems. Okay, so as always, I'll say that when I'm stating the problem, we should pause the video, and only if you cannot solve the problem yourself, you look at the solution. That's the ideal way of getting benefit from the videos. So question 221 says that if one root of the equation L minus m into x square plus Lx plus 1 is equal to 0 be double of the other, and if L be real, so that m is less than equal to 9/7. So pretty easy question. We let one root to be alpha, then the other root will automatically become to alpha. You see the type of double dot. So if one root is alpha, the other root will be double of that, 2 alpha. Sum of roots would be 3 alpha minus L by L minus m, or alpha will be, again there is a typing mistake, minus L by 3 into L minus m. Okay. Product of roots would be 2 alpha square, that is 1 by L minus m. You substitute value of alpha from here, you get 2L square by 9 L minus m whole square is equal to 1 by L minus m. So we get the equation 2L square minus 9L plus 9m is equal to 0. L is not equal to m because if L is equal to m, then this coefficient of x square will be 0 and then it won't remain a quadratic equation. So L is real in this, okay? Therefore, the discriminant of this equation would be greater than equal to 0. So we get 81 minus 72 m greater than equal to 0. So m is less than equal to 9 by 8. Okay, 9 by 8. There's a typing mistake here again. It should be 8. So quite a few typing mistakes. 1, 2, and 3. 3 typing mistakes. All right. Now we solve question number 222. If one root of the quadratic equation x square plus bx plus c is equal to 0 is equal to the nth power of the other, so that ac to the power n whole to the power 1 by n plus 1 plus a to the power nc whole to the power 1 by n plus 1 plus b is equal to 0. So if one root is alpha, that would be alpha to the power n. So we have the roots here, alpha and alpha to the power n, and sum would be minus b by a, and product would be alpha to the power n plus 1 c by a. So from this equation, the product of roots, we can say that alpha is equal to c by a to the power 1 by n plus 1. And from sum, that is this equation, we have a alpha to the power n plus a alpha plus b is equal to 0. Now, once we have this equation, we can put the value of this alpha in the equation and we get our desired equation. All right. Now, give me a moment. Question 223 says that if the roots of the equation x square plus bx plus c is equal to 0 be in the ratio p is to q, so that square root of p by q plus square root of q by p plus square root of c by a is equal to 0. So we let the roots be p alpha and q alpha so that their ratio is p is to q. Now sum of roots would be p plus q into alpha is equal to minus b by a, and product of roots would be pq alpha square, that is c by a. So from these two equations, we can say that alpha square is equal to c by apq. That is from this equation. So alpha is equal to square root of c by apq. Now we substitute this in the sum of roots and we solve, we arrive at the desired equation. Question number 224 says that if alpha and beta be the roots of the equation x square plus px plus q is equal to 0, find the value of the following terms of p and q. So we have alpha square by beta plus beta square by alpha. So if the let's see the second one also. Second one is omega alpha plus omega square beta into omega square alpha plus omega beta, where omega is the imaginary cube root of, this should be of unity. So from the problem we can say that sum of roots is minus p and product of roots is q. And then we have alpha square by beta plus beta square by alpha. We take the LCM, we get alpha cube plus beta cube by alpha beta. And we rewrite alpha cube plus beta cube in the form of alpha plus beta whole cube minus 3 alpha beta into alpha plus beta by alpha beta. So then we substitute the values and we get alpha plus beta as minus p, so minus p to the power cube, and 3 into q into minus p. So this becomes 3p cube plus, that is plus 3p cube. So 3p cube minus p cube, and alpha beta in the denominator is cube. So this is our equation. Now the second part is omega alpha plus omega square beta into omega square alpha plus omega beta. We multiply, we get omega cube alpha square plus omega to the power 4 alpha beta, omega to the power 4 alpha beta, okay, these two, okay. And then we have omega square alpha beta and then omega cube beta square. Omega cube in first and last terms would be 1. It will become alpha square plus beta square, and over here we substitute omega cube is equal to omega, 1. Omega cube is equal to 1, so it becomes omega alpha beta and omega square alpha beta. So these two, when you combine, will become minus alpha beta. So we have alpha square minus alpha beta plus beta square, which is equal to alpha plus beta whole square minus 3 alpha beta, which is equal to p square minus 3q. Now question 225 says that if alpha and beta be the roots of the equation a into x square plus m square plus mx plus cm square x square is equal to 0, prove that a into alpha square plus beta square into a plus alpha beta, plus a alpha beta plus c alpha square beta square is equal to 0. So we rewrite the equation, and that is this equation. We write in terms of x, we get a plus cm square into x square plus mx plus m square is equal to 0. Now sum of roots would be minus am by a plus cm square, and product of roots would be am square by a plus cm square. Now the equation which we have to evaluate is, that is this expression we write here, and we write alpha square plus beta square as alpha plus beta whole square minus 2 alpha beta, and then this term contains alpha beta, this term contains alpha beta. We plug in the values of alpha plus beta and alpha beta and you evaluate, it will be 0. Now we come to question 226. If alpha and beta be the roots of the equation x square plus bx plus c is equal to 0, prove that a into alpha square by beta plus beta square by alpha plus b into alpha by beta plus beta by alpha is equal to b. So pretty straightforward question again. We have sum of the roots as minus b by a, product as alpha beta is equal to c by a. We have this given left hand side of the equation, and we take LCM. In both the cases we get a into alpha cube plus beta cube by alpha beta plus b into alpha square plus beta square by alpha beta. We write alpha cube plus beta cube as alpha plus beta whole cube minus 3 alpha beta into alpha plus beta, and alpha square plus beta square as alpha plus beta whole square minus 2 alpha beta, and then we plug in the values, you will get the desired result. So solving is up to you. Question 227 says that if a and b are the roots of the equation x square plus px plus 1 is equal to 0, and c and d are the roots of the equation x square plus qx plus 1 is equal to 0, show that q square minus p square is equal to a minus c into b minus c into a plus d into b plus d. So since it is given that a, b are the roots of the equation x square plus px plus 1, we have a plus b is equal to minus p and ab is equal to 1. And similarly for the second equation, we have c plus d is equal to minus p and cd is equal to 1. Sorry, this should be q. There is not p. The equation is x square plus qx plus 1. So you see there are lots of typing mistakes. Once we have that, we evaluate a minus c into b minus c into a plus d into b plus d. What we have from the first two terms is ab minus bc minus ac plus c square, and from the second last two products we have ab plus bd plus ad plus d square. We write the first one as ab minus c into a plus b plus c square, and second one as ab into d into a plus b plus d square. We substitute the values of a plus b in both the equations. So you see a plus b is minus p, we substitute here, it becomes 1 plus pc plus c square into 1 minus pd plus d square. Then we expand again and just solve it, you will get the end result as q square minus p square. So I'll leave the calculation up to you. I don't want to indulge myself into trivial evaluations. Question 228 says that if the roots of the equation x square plus px plus q differ from the roots of the equation x square plus qx plus p is equal to 0 by the same quantity, so that p plus q plus 4 is equal to 0. So we let alpha beta be the roots of x square plus px plus q is equal to 0. That means alpha plus beta is minus p and alpha beta is equal to q. We let gamma delta be roots of the second equation, that is x square plus qx plus p is equal to 0. Then gamma plus delta is equal to minus q and gamma delta is equal to p. Now it is given that the roots differ by same quantity, so we can say that alpha minus beta is equal to gamma minus delta. You bring gamma this side and beta that side, it will become alpha minus beta is equal to beta minus alpha minus gamma is equal to beta minus delta, which will be equal. So similarly, we can say that alpha minus beta is equal to gamma minus delta. Once we have that, we square it and we write this as alpha plus beta whole square minus 4 alpha beta is equal to gamma plus delta whole square minus 4 gamma delta. That means p square minus 4q is equal to q square minus 4p. We bring everything to the left hand side, we get p square minus q square plus 4 into p minus q is equal to 0. We take p minus q common, then it becomes p plus q plus 4 is equal to 0. Clearly p is not equal to q, because if p is equal to q, then it won't work. Okay, so the other part has to be equal to 0, that is p plus q plus 4 is equal to 0. Question 229 says that if alpha beta are the roots of the equation ax square plus bx plus c is equal to 0 and Sn is equal to alpha to the power n plus beta to the power n, is then show that a Sn plus 1 plus b Sn plus c Sn minus 1 is equal to 0, and hence find S5. So somewhat better problem, not trivial. So we let alpha beta be the roots of the equation, then it will satisfy the equation, that is a alpha square plus b alpha plus c is equal to 0 and a beta square plus b beta plus c is equal to 0. Now sum of roots would be minus b by a and alpha beta would be c by a. Once we have that, we are given that Sn is equal to alpha to the power n plus beta to the power n. From the given equation, we plug in the value of alpha beta. Once we plug in the value, we take out alpha to the power n minus 1 from all the terms, we get a alpha square plus b beta plus c. And then we take beta to the power n minus 1 common, we get alpha beta square plus b beta plus c as the other factor. And we have proven that these two are 0, so this sum is 0. So we have Sn plus 1 is equal to minus b by a Sn minus c by a Sn minus 1. We substitute n is equal to 4, so we get S5 is equal to minus b by a S4 minus c by a S3. And then we recursively substitute, we get minus b by a S3 minus c by a S2. This should be 2 underscore 2. Instead of underscore, it has become minus. Once we have that, we repeatedly substitute S2, S1 and so on. We arrive at this value. So you can do the calculations. Question 230 says that if the sum of the roots of the equation ax square plus bx, and there is another typing mistake, is equal to 0, is equal to 0 is equal to the sum of the squares of the reciprocals. Okay, What it means is if alpha beta are the roots, then sum of roots, that is alpha plus beta, is equal to the sum of squares of the reciprocals. That is alpha plus beta is equal to 1 by alpha square plus 1 by beta square. We have to show that bc square, comma cs square, comma ab square are in AP. So from the given condition, we have alpha plus beta is equal to 1 by alpha square plus 1 by beta square. So alpha plus beta is equal to alpha plus beta whole square minus 2 alpha beta by alpha square beta square. We substitute the values and we arrive at this condition. CS square is equal to AB square plus BC square by 2, making the given terms which are required to be in AP. So with this, we come to the end of 23rd set. I went a bit fast because problems are simple, not difficult like before 210. So these questions, as I said, are very easy. You just need to perform the calculations, okay? I cannot, if I start doing all the calculations, it will take just a lot of time, okay? And in the PDF, I have skipped that because since the solutions are all given, at least there should be something the student should do. You see, there are lots of typing mistakes. Don't worry, I'll fix them after the video. So thanks a lot for watching the video. Do not forget to subscribe to the channel, like the video, share it on social media so that your friends can also benefit from this. Share it on WhatsApp to your friends if you don't use social media. Basically spread the word. The reason why I ask is that that's how more and more people can benefit from this video. And I say that this at the end of video rather than at the beginning of video, because I don't want to waste your time. In case you don't want to watch after the completion of video, you can skip this part. I say at the end so that people who have stuck to the end of video, that is those who are genuinely interested, hear this. So if you have questions, make use of comment box. If you want videos on certain topics, again make use of comment box. And I'll see you in the next video. Thanks a lot for watching. Happy programming. Enjoy. Programming 1 is reserved to the programming videos. Thank you.